Today, we're going to talk about lines. Not these ones, but the ones that actually matter. Lines are hugely important in pre-calc and calc, and especially the slope of a line is the basis for calculus. It's a fundamental. Am I right? Now, with this said, the goal of this video is to talk about lines, the formulas about them, and actually the application that lines give. Now, one of the biggest components of a line, and specifically line equation, is the slope. You know, rise over run. Ring a bell. You gotta rise in the morning before you can run. Y-axis, x-axis. You got it. Now, the technical definition of slope is m equals y2 minus y1 over x2 minus x1. It only gets better from there. What? Lines going uphill have a positive slope. Lines going downhill have a negative slope. Horizontal, the slope is 0 because all the y-coordinates are the same. Now, vertical lines, because the x underneath is 0, as we know, that's not possible, and if you try to, it's crazy. So, we say vertical lines have no slope. Now, one of the more basic equations that we should already know is the slope-intercept form, y equals mx plus b. Now, though pretty important pre-calculus, it's not really used that much in calculus. What we do focus on is point-slope form. Now, point-slope form is hugely important, especially once we're dealing with derivatives, tangent of a line, plugging it in. It really becomes helpful. Along with lines are the advent of parallel lines and perpendicular lines. For example, I have both of the pair drawn here. Here, we have perpendicular lines where the y-intercepts are the same, but the slopes are something called negative reciprocals of each other, where you have the negative sign out front, 1 over one of the original lines. Over here, we have parallel lines where the slopes are the same, but the y-intercepts are different. Alright, for our first example, we have just a very pretty simple example here. So, write the point slope with the given info. Now, of course, we know the point slope formula is y minus y1 equals m x minus x1. Now, we see they gave us the m, which is our slope, and a point. So all we have to do is plug them in. Now we don't know what y is, so we put y minus, but we know what y1 is, and that is our 0 here from the point. So y minus 0 equals negative 2, bring it down here, x minus x1, which are negative 4, so just minus 4, of course this changes to a plus. So this we can leave here, or, well, this is our final answer here in point slope, or we can get really fancy and write it in slope-intercept form, which this drops down nicely to. So we have y equals negative 2 x plus 4, and of course take the negative 2 and distribute it in. Y equals negative 2x minus 8. And there is the slope-intercept form. Up here is what the given was, as what we were asked, point slope. Y minus 0 equals negative 2 x minus negative 4. Here it is computer written out, so if you want to pause the video and copy the information, you can right now. For our next example, we have one that is specifically focused on slope. So, we have the question, find the slope that passes through the points 2, 5, and 7, 25. Now, as we know, rise over run, equation of slope, m equals y2 minus y1 over x2 minus x1. Now, for the 2 and 1, we can assign it to any point, but we have to make sure the 2's go together and the 1's go together. So, to do this, we will have m equals my y2, which I like to choose the bigger numbers first, so we'll choose 25 minus y1, which is 5, over x2, 7, minus 2. So we have this. Subtract. So we have 20 over 5, and that works out nicely to 4, which is our slope. Again, just like before, if you missed it, pause the video and copy down the problem. The use of lines has so many practical applications, especially once you get deeper and deeper into math-related topics. So, starting from basic level, the conversion from Celsius to Fahrenheit is a linear type of conversion in between them. In addition to that, whenever analyzing a graph, a linear regression, of course, linear is a line, so analyzing that, for example, the world population graph, using linear regression with that, you can analyze the data and then use it and manipulate it any which way you want. So that's two examples of countless ways that lines can be used, in math. And this is only scratching the surface. Now you're probably wondering, because lines are so cool, how do we make them easier to work with so we can use them all the time?
Wait, SpongeBob! We're not cavemen! We have technology!
Patrick, you are right. With the use of technology like a graphing calculator, working with lines is easier than ever before. So, get one of these, they'll be your best friend. Well, hopefully, you're now all expert on lines, using point-slope formula and slope-intercept formula by just plugging in what they give you, just manipulating it, and using your technology of a graphing calculator. Lines aren't that easy, and again, they are the basis for calculus. So being able to know what lines and slopes involve is the key to getting that A. Thanks again.